true that faster RAM can slow down to slower RAM? So slower RAM cannot go any faster. Well, it's no different than a freeway. If you've got a car that can only do 55 miles an hour, and you're in a Ferrari behind that slow car, you can't go any faster than the car in front of you, regardless of the make or model. So the same is true of RAM. If the maximum speed of a stick of RAM is 2666, and you've got one stick of 2666 and 7 sticks of PC 3000 or 3400 or whatever, that's all going to run at 2666. You can't go any faster than the slowest one in the group. Ideally, all your RAM should be the same speed and the same CAS latency, so this shouldn't even be a question you're asking. Always, if you can, use the same manufacturer, use the same RAM. If you're trying to upgrade your RAM and they don't make that RAM anymore, pull the old RAM and replace it entirely. That's what I would do if I had to support you. People that mix and match RAM sticks, those are people that have more time than I have, because it does tend to be something that is, you wait and see, you know, is it going to create a problem? I don't know. Just start using it and it starts crashing, you probably have an incompatibility. My customers and myself, we don't have time for that. It's got to work right. It's got to work right the first time. The amount of time lost productivity as a result of a machine that's not reliable will far exceed the cost of any RAM very, very quickly. Is it better to use 4 gigs of RAM than 2 8s, filling all the slots using both channels? No, it's worse. You have 4 RAM modules, then you have 4 RAM modules that can go bad. You'll consume more power and generate more heat and limit your ability to upgrade without first removing and freeing up those channels. Dual channel works fastest in dual channel, and quad channel, if you have a chipset that supports quad channel, works fastest in quad channel. But with quad channel, you'll have 2, which means you'll have up to 8 sockets, and with dual channel, you'll have up to 4 sockets. So that means you can have 2 dual channels or 2 quad channels, but they don't run any faster. So what you want to do is use the least amount. You want to take advantage of dual channel with 2 memory modules. So if you want to go with 16 gigs of RAM, you don't do 4 4s, you do 2 8s. And then you have 2 sockets free that if you want to add 2 more 8s down the line and double the 32 gigs of RAM, it's a 2-minute job. It's very easy. You'll also reduce the power consumption and reduce the likelihood of a memory failure of a bad part. If you have 4 parts, you have 4 parts that can go bad. If you have 2 parts, you only have 2 parts that can go bad. So you can tell me the math on that one. 50% less chance of a failure, less power consumption, less heat, and easier upgrade. Most users will never use more than 16 gigs of RAM. Unless you're a very demanding user, you're an enthusiast, or you're the kind of person that likes having 100 windows open at the same time, then and only then would you benefit from more RAM. So what happens with computer memory is very interesting. If you have too little, it'll drag. If you get up to about 8, you're sort of in the middle. If you go to 16, it's more than you need. When I speak for the majority of people, not specialists, not the extremists. If you're an extremist or you run an application that's extreme, then 32. And then very rarely do people have applications that exceed that. They do exist, but they're not very common. So what if you put 64 in? Well, you just wasted your money, because now, so you had this much memory and your performance was here. You put this much memory and your performance went here. You put this much memory and your performance goes here, and then you put this much memory and your performance doesn't move, and you put more memory and your performance doesn't move, and more memory and your performance still stays here. This is the most you're using. Bill Gates said the problem when you make a lot of money is the restaurants, once you make a certain amount of money, the restaurants don't get any better. And I think it's very interesting, because I never considered that. You reach a point of diminishing returns, whether we're talking about computer memory or we're talking about, in this case, money. A fascinating concept. When you look at the properties of the RAM, and you'll see
a parenthesis, it says this much is usable. It's because you're using onboard video. Video requires some RAM. So if you don't have a discrete graphics card, and by a discrete graphics card, I mean you haven't added a graphics card, you'll notice when you buy a graphics card, it comes with RAM. In fact, it's often a selling point. How much RAM it's got affects how much it costs. Those things are directly related to performance. So when you're using onboard video, which is the video built into the CPU with either AMD or Intel, it has to get RAM from somewhere. And the manufacturers, like if you go to Best Buy and you look at the pre-built systems, they'll say, or they used to say, shared memory. It's not shared, it's stolen. Shared means you could get it back. The only way you get that RAM back is to put a discrete graphics card in. So long as you're using onboard graphics, it needs memory to come from somewhere. And oftentimes in the BIOS, you can actually fix an amount of memory to it. Like maybe you want the default to be a large amount. In most cases, the BIOS is set to auto, and it will fluctuate how much RAM it needs based on what demands you're placing on your card, and it'll take more when it needs more. But it definitely needs a minimum amount just to get your desktop up and get your video up. And that's why you'll see less RAM available. But it's not that that RAM isn't there or it isn't being used. It's being used for the graphics card, and the rest of it's being used for the operating system. But it's all being used.
Now, ASUS is kind of weird about which RAM sockets they want us to use. Here we've got 4 RAM sockets. These 2 are black, these 2 are gray. So they want you to use them in pairs, separated pairs. Now on most ASUS boards, they want you to use sockets A2 and B2 first, which in this case are going to be these 2 sockets right here. This side, on some motherboards, this side doesn't open. You see how these open and close, these little retention brackets? This side on some motherboards don't open because if you had a graphics card in here, it would interfere with the ability for these to open. So on this side, on some motherboards, these do not open, so don't try and open them if the board you have is designed this way. This is our RAM. The customer's gone with Corsair Vengeance DDR4. That's 2 16 gig sticks of RAM for a total of 32 gigs. This is 3000 megahertz RAM. Here we've got the 2 RAM sticks with heat sinks on them. There they are. And these heat sinks are a safe place to hold the RAM. You don't want to touch the exposed, what they call gold fingers. Keep your fingers off the fingers. Here is the RAM module, and you can see I can just hold it just like that. There's no anti-static discharge to worry about because it would just be hitting this heat shield, this heat spreader. And corporations in the computer industry, they like to protect their logos from any sort of scratching. So watch for little bits of plastic that have to be removed because if they get really hot, the plastic can start to give off an unpleasant odor. So I'm going to peel off the protection on the logo. Now, if you're not sure which sockets to use for your RAM, always refer to your motherboard manual and it'll have a little diagram there. So what I'm going to do is the RAM has got a key in it, and basically it's a notch, and then the socket also has that notch as well, and that makes it so you can only install the RAM one direction. I can't flip it the other way, it won't go in. Again, if you're struggling to install your RAM, you might have it backwards. So what you want to do is you want to set the RAM into its socket with the proper orientation, and it just goes straight down, and it should align. Right? Just straight. No force, no pressure. Once you verified you're in the socket correctly, use your thumbs and push down one corner and the other corner. Doesn't matter which corner you start with, one at a time. Don't try and push them both in at the same time. Then we're going to repeat the same process with the remaining module. So again, I'm going to pull this plastic off of here, which just drives me crazy. I'm sure they could save a little bit in the manufacturing process by removing that. No one would ever care. So let's turn this around and let's get it lined up in the socket correctly. And then once again, one corner and the other corner. That's it. 32 gigs of RAM is installed. What a qualified vendor list is, the manufacturer of the motherboard has tested certain RAM and verified that it works with their motherboard. Untested RAM, they don't know if it works or not. So if you're investing a lot of money in a system and you want to make sure, without a doubt, that the RAM you're buying 100% has been tested by the motherboard manufacturer to be compatible, then buy the RAM on the QVL list. And not just the QVL list in the motherboard manual, because that's outdated. Go to the website because it's updated. There's probably 10,000 different RAM modules that can be used. The motherboard manufacturer doesn't have the time or resources to test every RAM module on the market. And some of the RAM modules they tested aren't even available for sale anymore. And new RAM modules that weren't out when they did the testing are available. So, the bottom line is, when RAM is on the QVL list, it's been tested to work. When RAM is not on the QVL list, it has not been tested to work. That's all that means. Doesn't mean it won't work. It means they haven't tested it, and they probably never will. Because this is Corsair memory, it's a big name brand RAM manufacturer, and the speeds of the RAM I know are compatible with what the board uses, I feel very confident we're not going to have any RAM issues. When there's new technology, like when AMD releases a new chip, oftentimes it's very sensitive to the RAM that's being used, and there's often a lot of BIOS updates that come out to help increase the tolerance allowed. But at first, and especially with new technology, it can be pretty darn important you get the right RAM, or you're dealing with issues. That's the joy you get for being first. This is a 9th generation Intel chip. And so RAM isn't really a mystery as far as how to make it work. Most RAM is going to work just fine on an Intel system as long as it's meeting the speeds required at a bare minimum. And then beyond that, it should also be fine. Maybe could be an incompatibility with XMP, highly unlikely on a system that's been mature for 9 generations. More likely on newer technology. Let's say we want to test our memory. Let's talk about that. This system has 32 gigs of memory. It's going to take a long time to test, but how do I know that that memory works? All right, I built a new computer, I plugged the RAM modules in, and the system boots and installs Windows 10. I don't need to test the memory, right? Well, that's up to you. Because I'm building and shipping this computer, I want to make sure that all of the memory works, not just the memory I'm using. There's a company called FRAM, F-R-A-M, and they make oil filters for cars. And I think in the 90s they had advertising on TV talking about the importance of not only changing the oil filter on your car in a regular interval, but choosing a quality one. And realizing the quality one is a little more expensive than the generic brand. And their slogan was, pay a little now or pay a lot later. And that's what we're going to do right now. We're going to pay a little now with our time using a free utility called memtest86. So what I'm going to do, I'm going to plug in this flash drive. Let's plug it in right back here. It's still like USB 2. Not that it matters, but just so you know. And here we go. It's a blank flash drive. We're going to open a browser. I don't care what browser you use. Doesn't matter. And we want to go to memtest86. Now you can follow this. This is intended to be step by step. Right here it says download now. We're going to click that. Not sure why that didn't work. Let's try that one. So there's a Pro Edition, there's the free. We're going to do the free edition. Image for creating bootable USB drive on a Windows, Linux, or Mac system. Perfect, that's what I want. And let's save it. Just see how fast that is. It's small. Open it, extract all. Click extract all, and then the zip file, all the contents of it get extracted into a folder. So just to avoid any confusion, let's close everything we no longer need. We'll do image USB, double click it. Yes. Select the flash drive automatically. We want to use that Lexar Firefly, that's the flash drive. Write the image to the USB, yes. Post image verification, you certainly can do that if you want to. This is the source file. So all I had to do is just check that box and click the right button. Now, it's going to completely erase your flash drive. So don't use a flash drive that has anything on it that you want to keep. Because as soon as, this is what this dialog is warning you about. You're going to wipe that flash drive entirely. That's what an image does. Yes, it is correct. They have my permission. Well, it's a 16 gig flash drive. All right, yes. Now, it's warning me again. Second warning. Continuing will cause destruction of any data that's on that flash drive, and it will be replaced with the image that you've just downloaded. Yes. This only takes a moment. So up here at the top, you'll see write in progress. And then here, we've got a progress bar. And this is only going to take a moment. Here we go, here we go, here we go. Almost done. Image completed. I wonder if my image completed. Yeah, it did. We're going to close that. We're going to close that. We're going to exit that. We're going to close that. And that is that. I did that on purpose. Just reboot it. And we'll hit F12 and try it that way. F12 should give us a boot menu. And then we can choose the Lexar UEFI right there. Now it's going to boot to memtest86, and you don't have to touch a thing. Here's my hands, nothing up my sleeve, right? Computer's just running. We're letting it run, no keyboard or mouse input from me at any point. You want to talk about hands-free. At the top of the screen, it says the test will start in about 2 seconds. 1, 0. And it runs. It's off to the races, and we're off and running. And you'll see the information provided here is the pass below. So I'm looking at the top right. The percentage of that specific test, the test address of the memory that it's using, and the pattern that it's using. And then on the left side, you'll see our clock and temperature of the CPU, which contains the L1, L2, and L3 cache on the CPU. It recognizes the memory as 31.8 gigabytes of RAM, and it's running at PC4 25600, DDR4, XMP 3200, but I do not have XMP enabled at this time. There are 13 individual tests. So again, if we look at the upper right corner, it says we are on test 4. There are 13 total tests, and some memory problems only occur when the memory gets hot. And so for that reason, it will repeat by default, by just leaving the settings alone, it will repeat this series of 13 tests 4 times. And if it passes all 13 tests, which on this machine could take an hour or more just to complete the first 13 tests, then it'll repeat that a second time, a third time, and a fourth time, and then it'll give you the results. But if at any point during any of these tests, the very instant it encounters an error, it will be displayed in the blank part where it says time and address mode, pass 1 of 4. Do you see the pass 1 of 4? And then errors 0. So right below that, typically in red or in a different color, it'll alert you to an error. Now, if you see an error, you can stop the test immediately. Then shut your computer off and unplug it from the wall and give it a second to drain the power out of the capacitors and remove a RAM module. If you've got 4 RAM modules, you can remove 2 of them. Then rerun the test again. If the error occurs again, remove the 2 that you left and put the 2 you took out. If the error doesn't occur, then you've narrowed it down to one of the units you've removed. That's a game of swap. It is simply the process of reasonable deduction. Sherlock Holmes would be proud of you. But it's incredibly simple. The tool is completely free and everybody can make it. So what are you waiting for? Does your RAM have any problems? And if you've never used that much of your RAM, are you living in ignorant bliss? So a link from MTest 86 is in the video notes below the video, completely free. It's like watching a pot of water come to boil. It feels like it takes longer if you watch it. This is best to be left alone. Go out shopping, go watch TV, go to bed. Like I say, the results will be the results. But if at any time an error pops up, you can stop the test. There's no point in continuing the test. Memory is not repairable. You cannot fix it. You'll have to either replace it or live without it. You do see it's 91% at the very top of the screen. It says Intel Core i7, and just below that in green, it shows us we're 91% through test 13, and then below that I think is a percentage of all the tests combined, how close we are to the end. We're close, we're getting there. Many of you watching right now have bad RAM and you don't even know it because you're not using that area of RAM that's bad. Ignorance is bliss, and if you want to live with bad RAM, go ahead. The only reliable way that you can know if you have bad RAM for free is to download this utility and use it just as I've demonstrated here today. And so, if nothing else, it can give you peace of mind. Even if you don't think you have a problem, doesn't mean you don't. And so to get that confirmation back, that's much more useful than looking at your temps and worrying about how many frames per second you're getting, in my opinion. Thank you for watching this new quick tip series of videos, and I hope you enjoyed it. If so, you can let me know by clicking the thumbs up button below the video. And if you want to be alerted anytime new content is posted to my channel, be sure and click the subscribe button. After that, you'll see a little bell icon appear. Be sure and click the bell icon and make sure that the notification button is checked and how you want to be notified. That's going to wrap it up for this video. I'll see you all again very, very soon. Until then, bye for now.